Introduction to Functions. This is Differential Calculus, Fundamentals and Applications. Given two sets, x and y, a function f is a rule, a mapping, or a pairing. Okay? So we can look at f in three ways. We can look at it as a rule, as a mapping, or as a pairing that assigns elements of x to exactly one element of y. This pairing produces a set of ordered pairs. And this is how you write the elements of that set, okay? The elements of x, x sub I, each of them is paired to an element that is found in set y. This is not the first time you are listening to a lecture in functions. Functions were introduced to you way back in grade 8, junior high school. So that is like 5 years ago. So we have these two sets that arise from functions. We have the domain. Okay, so that is our notation, d sub f. So these are the elements in x for which the function is defined. We have the range of your function. That is our symbol. And then the range of the function is the set of elements in y, or elements of y that is paired with the elements in the domain of your function. I know that ever since functions were introduced to you, you had always been talking about functions that are defined on the set of real numbers. And in fact, for the most part that we do in math, it's always about the set of real numbers. But functions are not confined on the set of real numbers. In fact, there are so many functions. In fact, there are many things or many processes in physical reality that embody the notion of a function. So for example, let x be the set of animals. So x is a set of animals, and we will pair a few selection of vertebrate animals to its class in the animal kingdom. Those classes are listed in set y. Okay, so how about the frog? What is the class of the frog in the animal kingdom? A frog is a vertebrate animal. So what is its class? It belongs to the class of amphibians. Crocodiles, or a crocodile, is also a vertebrate animal, and its class or classification in the animal kingdom would be the reptiles. For this particular fish, it's the fish. And by the way, this fish, if you came from Mabini, Batangas, you are familiar with this fish. When I was a kid, I used to fish with my father, and we call this maming. This one is another fish. This is a tuna. And this one, the owl, okay, we are pairing it to the class of birds. Have you seen an owl? We have owl in our province. Okay, if you go to Lima, and if you will pay attention to the sound of the ambience, which is Lima, especially when you are there in the quadrangle, sometimes you will see the hoot of the owl. Woo, woo, woo. So the owl belongs to the class of birds. And this one, the rat, belongs to the class of mammals. So this thing illustrates to you what a function is. It is a mapping from set x to y, in which elements of x are assigned to only one, or to exactly one element in set y. Okay, so functions need not always be defined on the set of real numbers. It can be defined on a set of people. So for example, our set x is the set of students in Omicron University. Y is a student number in that university. So we shall define f to be a function that will assign to a student a unique student number. Okay, so we will assign exactly one student number to each student. And so again, the notion of function embodies pairing, matching. We can look at function also as an operation or as an action. It is an operation that acts on an input and produces a specific defined output or outcome. And we see this everywhere. We see this everywhere. We see this in ATM machines. We see this in vending machines. We see this, for example, in grading systems. Okay? So we have an input. This input will enter a predefined process and it will produce a specific output. So let's take, for example, the ATM machine. So it's not the ATM machine that is the function, okay? It's the operations, it's the software, okay, that is built into the machine that embodies the notion of a function. So your first input can be your ATM card. So when you insert your ATM card into the ATM machine, the software that is built into the machine will act on your ATM card and it will produce an output. The first output is a message, something like enter your PIN number. Okay? And after entering your PIN number, okay, so the next input would be your PIN number, and then the algorithm that is built into the machine will act on your PIN number and the machine will produce an output. That would be a set of choices, a menu. So the screen or the machine will prompt you, what do you want to do? And then you will choose or you will press a button. So the things that is happening in an ATM machine is an example of a function. It's also the same with the grading system. Okay? So the grading system is a predefined process. We have a rule about how to give you grades. So the input to your grades will come from many things. Okay? At least in our subject, it will come from your midterm performance and final performance. And even those two performances came from 3 or 4 more things. So your final grade in differential calculus will come from 2 input, your midterm performance and your final performance. And then it will enter the grading system and it will compute what will be its corresponding final grade. Okay? And the output would be the numeric grade that you will see in the student portal. So many things around us embody the notion of a function. Okay? And especially for you being into IT and computer science, the things that you do, the algorithms that you do, the coding that you do are meant to act on an input in order to produce a specific defined output or outcome. So the notion of a function is not confined to the set of real numbers.